What's up, dev team? Hope everybody's doing good. Hope everybody is doing great. So in this video, I will be showcasing how to backport the sprint animations from 5.5 of GASP to 5.4 of GASP. So I tried to make a video recently in regards to this. It was basically yesterday. So as of today, November 19th, 2024, I tried to do it on the 18th, or I did do it on the 18th. But encountered some issues where my computer crashed on me and I was able to salvage it. But then, the next morning, so today as of 19, I tried. Basically, when I woke up, I skipped the gym and I wanted to work on the video, but there was a lot of bad audio stuff happening and I just was not worth my time. And also too, like collectively total the video that I did would have ran like really over an hour, like an hour, 15 minutes, stuff like that. So I want to cut them into a little bit of two segments, right? I want to do a sprint one and I want to do a crouch one. So I will be doing two-part video to this, so we're going to focus on the sprint one today. So, as you can see, I already am in 5.5. So when I go ahead and hit play, you already know what it's about, where we got the sprint animations in here. So one of the things that we are going to do and look over is, as you can see, that we have sprinting when we're going forward or, at a specific angle while going forward, right? However, you'll notice that if I'm holding the shift and I go left, or I go right, or I go back, we are technically in a run, because if you were to ever do debugging with your chooser table when looking at these sprint animations, or at least the sprint chooser, that when we actually have strafing enabled or going on, right, that we go into our running animation, so it cancels out. And I know what that is, and it's a pure function called CanSprint within the game animation 5.5. So we are definitely going to be implementing that, and as you can see up above, that I've got the PSDs ready, because there are specific settings that we got to make sure that we have for our continuing pose bias and looping costs, stuff like that. So we're going to run through this video and get all that set up for the sprint animations. So let's go ahead and get started, right? So what I am going to do is we do need to go into our content browser and we need to drill down to our sprint animations. So you're going to go down to characters, UEFN mannequin, animations, and then you'll see the folders right in here where the animations are currently stacked at. So the one we want to focus on in sprint, but we also need to grab some from the jump, because we have land animations that are lands light, lands heavy, that we need to pull from here, and they are in the jump. So we do need to grab those, and what I'll be doing for those is I'm going to be putting them in the same folder as sprint when we migrate them into 5.4. So we are not going to be necessarily doing a true migration, because I'm going to explain that in just a moment when I go through what we're actually going to be doing. So for the moment, let's go ahead and go into our sprint here. And what we're going to do is we're going to click on one of these and we're going to highlight all of these using Control A. And what we're going to do is you're just going to right click on one of these and you're going to go to Asset Actions. And what we're going to do is a bulk export instead. So the reason that we're going to be doing a bulk export instead of a migrate is because I believe there is something to do with the different versions and maybe of how they're, coded, programmed, whatever, where I don't think it allows for backwards compatibility of versions, like engine versions, right? Because you have different stuff in place or different programmability in place, or, for lack of better terms, right? Because even for me in IT, right, because I do IT, that there are some things where it's like you can't do it because like the versions aren't compatible. You can't go back this because then certain things will work, or if you go forward, like things have changed, stuff like that. So there could be any sort of reasons as to why you can't do a migration, because it will let you technically migrate, but when you go into 5.4, that you are going to have an empty folder with just a blank animations, right? It's just not going to be there. They're not going to exist. It'll say completed, you just won't have it. So what we're going to do is after you hit bulk export, what I would like for you to do, you don't have to do this per se, but it makes it cleaner and nicer to maintain because we are doing exports. So for this video, we're going to just strictly work on the sprint, but in the next video, we will be working on crouch. So I have a generic folder where I like to hold my assets because that's where I have Humble Bundle, Cinti stuff as well, where I've gotten online, you know, for a cheap price, like whatever, and I hold them here, especially since Fab is a thing and I can't like I don't have like a vault to put these in. So I put them here. And so what we're going to do is, if you don't already have one, just create a generic top level folder to hold your assets. So I called mine Unreal Project Assets, just so it's kind of right next to my projects. And we're just going to click on that folder once you've created it, or wherever you decide to put it. And we're just going to hit select folder. And what we're going to do is we're going to leave every single setting as default, because I've played around with this. I had to do some Google searching as well, do a lot of research in regards to like what these are doing. And there's a bunch of information that goes into this that I'm not going to necessarily go over as far as this goes, just because a lot of them don't pertain to the export that we're trying to do. But you just want to keep all of these settings as default. But the one thing you do want to ensure is the FBX export compatibility. Make sure that it is on 2020. So when I first initiated this like some time ago, it was on 2013. If it is on anything but 2020 for y'all, go ahead and just click on FBX 2020. And because here's the thing, I've tried these different versions, but I think they're for different engines, because I have tried a few of these other versions based off of recommendations of Google and stuff like that, or you know what I found on Unreal Engine forums, and they were for previous versions. I don't believe, like, unless you're working on a certain version, that these are gonna, you know, not gonna work, or they're gonna work, whatever. But I think for the 5.xx engine series of Unreal, 2019 or 2020 should work, but we're going to keep it as 2020 because I think 5.4 and 5.5 are utilizing the 2020 version. So go ahead and make sure that that is selected. And once you have that checked, go ahead and hit export all and let it export all of the animations. So as you can see, we only had 44 sprint animations. So once you have that, if I open up my folder, so I already had it open, I'm bringing it to the side. So where you've selected it to, you know, to be exported to, you should now have a game folder with characters, UEFN mannequin, animations, and then the sprint. And then you'll notice that all of these sprints are here. So go ahead and open up your folder all the way down to the sprint, because now we are going to inject this into 5.4. So what I'm going to go ahead and do is I'm going to pull up my 5.4, move it over here, and then move the 5.5 over. And now what we're going to do is we're going to open up our content drawer in our 5.4. So if you're not already there, if you don't have 5.4, you know, go ahead and pause the video until you catch up to this point. But for right now, you know, I'm going to move on with it, but so in our 5.4, go ahead and open up characters, and let's drill down UEFN mannequin, animations, till we get here. And what we are going to do is let's create a new folder called Sprint, just like that. And now we're going to go into Sprint, and what we're going to do is within our folder, highlight all of the animations, and you're going to just drag them into here. So now what we're going to do is everything is going to be left as default here, but we do need to select our skeleton here. So go ahead and look for UEFN mannequin, because that's what we want to make sure to associate the animations to, and hit import all. And so it should be very quick for this, or fairly quick, just because there's only 44 animations. When we do the crouch in another video, there's over 200 animations in there. It is going to take a while, so I would cut through that. So, you know, but for this, it should be relatively quick. Because what we're going to do is once this finishes and we confirmed a few things, then we're going to go hop back into 5.5 and get our lands. So as you can see, we now have the animations, but you'll know that they're a bit off. You'll notice that they're a bit offset, but that's because they didn't move over with force lock or root lock and root motion. So what we want to do is, while they're all highlighted, is just right click on one of them and go to asset actions, and then do edit selection in property matrix. So with that, I'm going to go ahead and dock that in here. All of the animations are here, so go ahead and click on one and hit Control A to highlight all the animations. And then through here, what we want to do is go ahead and go down to the root motion in the details pane and check the root lock and the root motion. And then once you've done that and confirm that, go ahead and hit save. We're not going to be doing loop just yet because there's only a select few animations in here that we're going to be doing loop for, but we're going to enable looping when we actually go through the post search databases. So once you've done this, let's go ahead and close out of there. And now what we are going to do is I'm going to drag back over the 5.5 because now that we have our sprint, what we're going to do is we're going to go back into animations here and we're going to go into our jump. So now within jump, what you want to do is look for sprint and you will see all of our sprinting animations here where we have our sprint heavy landings, our sprint light landings, and our starts. So go ahead and select one and hit Control A there. And we're going to do the same thing here. We're going to go to Asset Actions and then Bulk Export. And then we are going to make sure to choose our generic top level folder that we've created to house these animations. So go ahead and hit, click on your folder and hit select folder. And then again, leave everything else as default, but make sure that the export compatibility is set to 2020. So once you've gotten that and confirmed all that, hit export all. And then now if I bring in my full file explorer and I go back to animations, you will now see that we have jump this time, but we have all of our sprints. So that's why I wanted to kind of circle back around just to show you that it's going to be a jump thing now. But now here's the deal, right? So let me go ahead and move 5.5 over because we need to go back into the 5.4. So with the 5.4, if we go into content drawer, there's a, if we go to animations, you can choose where you want to set it, but I'm going to show you my method to my madness, where you have your jump and you have your sprint, right? Where all your lands heavy, all your lands, whatever starts are in your jump. Well, for the moment, because we're going to be going through post search databases and stuff like that, the method that I choose to do is I'm going to put those sprint stuff, the lands, heavy, light, jumps, or starts, into the sprint just to keep all of these sprint stuff for the moment in one place until we finish setting up our post search databases and stuff like that. Into which case, then you can then move your, the jump stuff over to the jump folder. And this is just because I want to make it quick when we go through the post search database stuff. So that's the reason why I'm doing that. So for the moment, choose where you want to put it. But for me, I'm going to put it in the sprint temporarily just to keep all the sprints together while we go through this. So I'm going to just drag and drop like we did with the previous animations. And then everything is going to be default. But for the skeleton, same thing. We're going to look for UEFN mannequin to select that and then import all there. And then once it's imported those animations, just like with the, the on-ground animations, they are offset now. So we need to right click here and go to Asset Actions and then Edit Selection and Property Matrix. So in here, go ahead and Control A, click on one and hit Control A to highlight these and do the same thing. We're going to go down to Root Motion in the Details pane and make sure that both of these are checked. And then we are going to save and then close out of that. So now once you've done that and have all the sprint animations open or over, we are officially done with that part. So now we can move on to the next segment where we will now focus on making the post search databases. So right now, let's go ahead and go into animations and then motion matching data. And then we're going to go into databases. And then once in databases, we're going to go to dense. And then here's where we're going to put everything together. So for this video, we're just going to create a new folder and we're going to call it Sprint. And here's what I'm going to do to make it easier for us is what we're going to do is that we're going to look for our running stuff in here, our post search database stuff, but we're going to look for running lands heavy, running lands light, loops, pivots, stops, and starts. So what I'm going to do is I'm going to type in run just so we can keep the runs together. So there's going to just be 6 things that we need. So we don't need the from traversal, and we need this lands heavy right here, this lands light right here, this loops, the pivots. We don't need spin transition. We want the starts and we want the stops. So just like so. Once you have that, go ahead and hit Control D on your keyboard, which will duplicate those and also undo the filter that we have. So that way we can then take these newly duplicated pose search databases and click and drag and throw them into the Sprint folder, where we are going to then say move here. So that way we can kind of have them out of the way. So now let's go ahead and go into our Sprint folder, and what we're going to do is we're going to rename all of these. That way we can get rid of the one at the end and also change all the runs to sprints. So I'm going to go ahead and fast forward through this part, but go ahead on your end. If you need to pause, go ahead and pause, but get rid of the one that's at the end of all of the names, as well as rename the run to sprint. So that's what I'm going to do now. So I will see y'all in a bit. Alrighty, dev team, I am back. I am done. So once you've done your part, let's go ahead and throw open all of these to where we're going to dock them in our editor, because I want to have them all open at the same time. So that way, as we finish through them and go through them, we're just going to close down the ones we've already done and saved. So it just kind of makes it easier for us to keep track of, what we've done, stuff like that, right? So, because once we get through these, we're going to go back and do our heavy and go through those motions. So now that we got all of those open, or at least, it's going to take time for mine. So let's go ahead and head back into the lands heavy. And we're going to go ahead and highlight all of these, and we're going to delete them out of there. So now for our heavy, right? So what we're going to do is we're going to look for 2 animations, because there's only 2 animations that we need. So we're going to go back into our animations right here, and we're going to go into our sprint. And that's why I wanted them all in one place as we work through them, because I didn't want to, it's one folder to flip through where it's like, oh, it's in the jump, whatever, but all of our sprints here, so I could just pop back up and then just keep going, right? So here we go. We have the heavy L foot and then the heavy R foot. So go ahead and grab those and throw those in there. And then for this, what we want to do is we want to deselect the reselection of poses to, kind of have them similar to what's in the motion matching databases in the 5.5. And then in 5.5, they have jump selected here. They have the continuing pose bias the same, and the base cost the same, and the looping cost the same. And they also have it as dense all here. So, once you've confirmed that these are the settings that you see on the screen, you can go ahead and hit save, and we can close out of the lands heavy. So now we can go into the lands light. So get rid of all of the lands light that's in here. And what we're going to do is there should also be just 2 of the lands light. So it should be, light foot, left foot, light right foot. So go ahead and drag those in there. And then same thing that we did for the heavy, we're going to deselect the reselection of poses. We want it to be on jump. The continuing pose cost is going to be 0.1. The base cost is 0. The looping cost is 0.05. And then the dense all for the normalization set. So once you've confirmed this setup, as well as the animations in here, we can go ahead and save that and then close that window. And now let's get into our loops. So with the loops in here, go ahead and delete all of those. And then there's not too many loops for here for the sprint, or at least there wasn't too many as far as pivots and stuff like that. But in regards to that, what we're going to do then is for that, we're going to look for our loop. So we want to get the loop F, and then loop FL, and then FR, because what this is forward, forward left, and forward right. So now for these, what we want to do is while we have these selected, go ahead, and this is where we're actually going to enable the looping, because like I said earlier, there's only a select few animations we want to check looping for. So for these loop animations, we want to go to Asset Actions, Edit in Property Matrix, and make sure to highlight all of them. And then you are going to go into the Details pane and select Loop right here. And once you've got that checked, go ahead and hit Save, and then you can close out of this. So now let's hop back into here, and now you should see that we have looping. And the last thing that we need to do is deselect the reselection of poses. But now there's a few more animations we need to add. So we want to get our transitions. So we have run to sprint transitions and we have walk to sprint transitions. So we should be able to just type in transition here and get those. So yeah, you see we have run to sprint, left foot, run to sprint, right foot, then walk to sprint, then, you know, right foot, left foot here. So let's go ahead and grab all of these and chuck those in there. And then for these, we're not setting up looping because these are transitions. We want them to just happen, you know, like at one point. We don't need them to loop through. So for this, we're going to also deselect the reselection of poses here. And then down here in our details, we do want to leave it on default, and the continuing pose cost is the same, the base cost is the same, and the looping cost is the same, and then our normalization set is the same. So once you've confirmed this setup, you can go ahead and hit save, and then we can close out of this. So now let's work on our pivots. So for our pivots, there's not going to be too many animations here because as you can see with the run, there's a bunch of stuff like they got diamonds and stuff. We don't need to worry about that here because for sprinting, there's only some like forward facing, you know, animations we want to play because you're going to be kind of hard pressed in real life to sprint left, right, or backwards. So they're not going to really have too many, you know, animations for this. So they did a pretty good job on this one. So we're going to go ahead and open this back up. And what we're going to do is for the pivots that we want, they are not called pivots, they call them diamonds. So just like that, because you'll see in a minute when we throw these in there, so highlight and select all of those and throw those in there. When you look at how the diamonds work, you can see how they're transitioning, right? Where they're going in a diamond-esque pattern when they move. So that is their form of a quick pivot in a sort of sense, right? So once you got those in there, let's go ahead and deselect the reselection of poses. And now there's some other animations we do have to throw in here because what they have are turn animations for when they're doing the quick turns when sprinting. So when we throw these in there, so highlight all of these and chuck those in there. For the turns, you'll see how they do it like quick turnarounds. So if I, you know, move back so you can better see this, you can see how they're doing those turns for when we're going left, right, or just straight up turning around. So once we got those, for this, we do want to leave these checked because we want to make sure that those get reselected within this because of, you know, how they function as far as the true pivots go. So for this, we want to make sure that the schema is on default and the continuing pose cost is the same, the base cost is the same, looping cost is the same, and normalization set is dense all. So once you've confirmed this setup and these animations, go ahead and save this and close the window. So now we are on our starts. So for the starts, shouldn't be too much for here. There's a couple different animation types here. So go ahead and select all of these out of here and delete those. And then go into the content drawer, and the first type that we want to pull up is the reface, because what this is for is when you go to start, depending on where you go, you want to reface your character to the proper direction of where you're going. So when you look at it, you can see how they reface the proper direction before they, you know, in order to start sprinting. So that's what the reface is actually doing, is just let's redirect ourselves to face the direction we want to move in. So for those, we're going to leave these on. So we want these to be reselected. There's no looping or anything like that. And then the other animations that we need to grab out of here is our start. So I know I typed in start as pretty generic. We do not want the jump starts. We want to get the, there's some basic starts out of here. So we want to get the, not front right L. We want to get the forward. Where is it? That's FL. True sprint. Yeah, we want this, and then we want this. Yeah, so, oh, no, I didn't want that open. Shoot. Hang on, guys, my bad. I don't know why I double-clicked that. So these are the ones that we want. We want the neutral sprint, start, forward left foot, and then start right foot. So, you know, once you got that, we can go ahead and check our database details. So we want to leave this on default, and the costs are the same that is in 5.5, and then the normalization set is dense all. So once you've confirmed this and these animations, you can go ahead and save these, and we can close out of that and then go into our dense stops. So for here, let's go ahead and wipe out all of these here. And then let's go ahead and grab our stops. So this one should be pretty simple. There should only be like 2 stops, I believe. There's a couple, but we only need specific ones. So look for the F left foot and the F right foot. So these 2 first ones, and plop those in there. So for these ones, go ahead and deselect the reselection of poses. And then what we want to make sure is that we have our stop database here. The cost is at 0.2, which is the same as in 5.5. This is the same. Looping cost is the same. And then make sure that we have dents all selected here. And once you've confirmed the animations and the details, you can go ahead and save this, and we are officially done setting up our databases. So now what we want to go ahead and do is let's go ahead and throw these into our chooser table. So go ahead and open up the motion matching data, and then into the pose search databases dents, go ahead and open that up and throw that bad boy up into the dock. And now what we are going to do is, this should be very simple. We're going to add a row, and we're going to add a nested chooser, because we're going to make it similar to the other ones where, there's stuff nested inside of these. And this one is, it's going to be called, do new nested chooser and call it the sprint, or not sprint, stand sprints. Because in 5.5, they call it stand sprint, but I think they just kind of forgot to put the S in there because you have a lot of sprint stuff in here. So go ahead and call it stand sprints, and I'm going to move it underneath of the runs. So once you got that, we can make our adjustments on this top level accordingly, right? So we are going to be on ground when doing these. We're going to be standing, and we're going to be moving, and then our gait, we will be sprinting. So now another thing too. So with this, what we want to do is we want to go into our idles first, because we want to put our stops in here. So what's cool, if I bring this back over, or my 5.5, what you'll notice is in 5.5, they actually have infinity symbols where it's like, hey, it doesn't matter at this point. If you meet these other requirements, as long as you're within this range, do this. So we have an infinite minimum and an infinite maximum. So these are relatively pointless, but as far as these sprint stops, you can see that for our floats and stuff like that, they have it, at 550 with infinity, as the max level, but we'll never really reach infinity unless you're doing something extra, right? Like increasing stuff. But in 5.4, we don't have infinity. Our infinity is basically 999, but you can set it to something as great as, like, I believe you can do 99999 if I remember correctly. Yeah, so you can even set that there if you wanted to, but for simplistic purposes, we're just going to keep it at triple digits. So go ahead and in the stand idles, throw in a new row for asset, and we're going to call our sprint stops here. So go ahead and search for sprint, and then grab your stops. And then you're going to chuck that right in here, or at least move it up to where it's underneath the run stops. And so then for our gate, what we are going to do is we're going to make sure that this says sprint. And then in here, you'll notice that they have the different speed 2Ds for each of these. So what I'm also going to do is kind of match it with the 5.5, where they have the run sprints or run stops at 100 to, infinity or 999. But the sprint stops, they have it at 550 to, 999. Here. So we're going to kind of match that with what they have there. And then what we want to do is make sure that everything here is nice or, correctly set. So we're going to set this to false because we're not landing light or heavy, but then we're going to keep it as any just in case we are turning in place. So go ahead, and once you got that set, go ahead and save. And we're going to hop back into the top layer. And now what we are going to do is, I believe, no, it's going to be in the, not in the air. I forgot it's going to be in the sprints, because this is where we'll have our from traversed and stuff like that, right? So for here, what we're going to do is we're going to set up 5 asset rows. So go ahead and do add row, and you're going to set 5 assets. So, once you have that set, we're not going to do anything with these just yet, because now we're going to make the columns before we set our database tables. So go ahead and here, just like in 5.5, we want to add 4 Boolean columns. So go ahead and hit add column and do bool column, and so until you have 4 columns. So then once you have that, go back to the first one, and for the first Boolean column that they have, you're going to go into the sandbox character and you're going to do is starting. Then for the second one, you're going to go back in and grab the is pivoting. And then for the third one, go back in and do the just landed light. And then for the last one, you're going to go back in and get the landed heavy. So now what we can go ahead and do is let's go ahead and throw in our assets in here. And we're going to, start off with our loops. So go ahead and get our CanSprint loops. Then go into the second one and grab your CanSprint starts. And then grab your sprint pivots. And then your landed lights. And then your lands heavy. Just like that. And then for this, most of these are going to be left on any, but there's going to be certain ones that we change to false and others that we set to true, right? So for our starts, we're going to set this to true, but everything else is going to be left as any. Then for our pivoting, we're going to set the sprint loops to false and the starts to false, but the pivots we're going to set to true and leave the rest as any. And then for the lands light, the first 3 are going to be left as any, and we're going to make it true for the light lands and false for the heavy, and then vice versa over here. We're going to do false for the lands light and the true for the lands heavy, and everything else just is any. So now once you actually have this set, you are essentially good to go. So however, there's a caveat to this I'm going to go over and show y'all, because I do have some explanations for what I'm about to show you. So let's go back into the default level and take a look at what I'm going to show you, right? So now that we got everything there set up, and in our character blueprint, we should have the sprint already connected. I believe it's the crouch that's disconnected. So when we go ahead and start, if I hit shift, should be sprinting. Not sure why it's sprinting. Let me make sure. Oh, I know why. I forgot that this was 5.4 and this is a fresh version. So if it is a fresh version for you guys, you need to go back in here to content, and you want to open up your blueprints folder and go into the character sandbox, because what we need to do now is we need to update movement. So go into update movement, and we want to go into the get desired gate, and we want to change this to sprint. So that's what I forgot to do. So just to double check, just to make sure I didn't get anything else wrong, let me just double check. Yeah, so that's why I thought the sprint was connected. So I was right on that one. It was just I forgot to do that because this is a fresh project. So my apologies, guys. So now when we do it, you can now see that we're running, right? So we got our sprint, or we're not running, but we're sprinting, and you could see that we have our, diagonal patterns, right? However, there's one thing that you'll notice. Notice how I'm kind of sliding, right? But then if I strafe left and then strafe right, you'll notice some glitchiness with the animations and stuff's not playing right. And there's a reason for that. Because now we got to set up some other factors. Because this, as you'll see, if I go into the update movement and then into get desired gate, we now need to modify this because there are certain factors at play. So let me actually go ahead and move 5.5 over so I can show you what's going on. So you'll notice that in my event graph, I do have this CanSprint because I want to show you this. So I'm going to connect that, and I'm going to show you something. So if we hit play in 5.5, you'll notice that as soon as I start sprinting, I have true, right? So, cool, I'm sprinting, I'm getting it, we're good. But then as soon as I turn around, notice how that says false and we're still sprinting. So there's a bit of an interesting thing at play here. So let's go ahead and go into the CanSprint, because this is what we do have to now look at. So as you can see here within the CanSprint, and if you're not sure where this is at, it's going to be in the update movement pre-CMC, and it's going to be get desired gate, and then right here you'll see the CanSprint. So within the CanSprint, you'll notice this setup, right, where we have get character movement to get current acceleration that leads into false on the select node, get pending movement input vector that's set into true of the select node and then is locally controlled of the index of the select, that then feeds in the rotation from X vector, that then feeds into a delta rotator, with also the actor rotation getting fed into the delta, to where we return our Z value for our yaw to get the absolute value of it, to then get 50-degree angle, to then get fed into the select, where we check to see if we are strafing or not. And then if once the sprint's true and this is true, then we feed it the output into here. So let me go over what everything does, because I want to go over what they do here, because we're going to quickly run through it and recreate it in the 5.5, except we're not going to use this, but I want to explain what this does anyway. So let's start with the get actor rotation first, because it's part of A right here off the delta rotator. So I'm going to start up this way and then work down. So for our get actor rotation, hopefully everybody knows what it does, but in case you don't know, or if you are especially new to Unreal Engine and you're not sure what the get actor rotation does, what this node does is it retrieves the current rotation of an actor in the game world. So basically this rotation is represented as a rotator, as notated by the return value and how it looks grayish kind of, which includes three components, which is our pitch, which is your up and down, so it would be your Y, then your yaw, which is your left and right rotation, which is your Z, and then your rolling, which is your X, but your rolling is more of a barrel roll. So, for example, if we go into the viewport and we look at our character from here, when we do our rotation on the degrees, if I do 45 degrees, you could see that we're doing a roll around the X, because the red is our X. So we're rolling around. So we're essentially doing this along the X. So kind of like a barrel roll, right? So then if I go, 90, we keep going, 135 or, 180. 270, then like back to 0, we've essentially done a barrel roll. So that's what that is doing. Then for the Y, what this is doing is checking to see that we, are looking up and down. But for like this case, what it's going to end up doing is, as you can see, it's going to rotate us, like barrel roll us this way. But in a sense, for our actor rotator, what this actually truly does is it allows us to look up and look down, because that is what our pitch is. This is kind of a bad example of what I used, but essentially for our Y, we are looking up and we are looking down with our character. For our X, we're essentially doing this, where we're barrel rolling, around. That is what the roll is doing. But then for our Z, what this does is allows us to look left and look right. So you're spinning around the Z or the blue right here to look left and right. That is our yaw. So that is what that is doing. So when we do that, what we're trying to do is, get those three vectors. So what, basically a simple explanation of what this is doing is it's giving you the direction your character is looking at any given moment. So that's what that is doing. So before we get into the delta rotator, let's go ahead and go back over here so we can feed into B. So with what our get a current acceleration is doing is we're obtaining our character's current acceleration vector, that's applied within the character movement component. So, acceleration, it refers to how fast the character's speed is changing over time, not just the speed itself. So it's more so the vector indicates both the direction of magnitude or the strength of the acceleration. So, for a simple explanation, right, it's like checking that, in which direction and how strongly is the character starting to move. So it's useful for understanding how the character is beginning to move, especially when responding to player input. So this allows us to get up, to change our velocity over time, essentially. So then we have the get pending movement input vector. So this one's pretty interesting, and what this does is it fetches the movement input vector that the player has provided but hasn't yet been processed. So what this is doing is it represents the direction the player intends the character to move based on input devices like keyboard, mouse, or gamepad. So what this does is if I hit W on my keyboard, the pending movement input vector would be W forward, and it has to process that, and we intend our character to go forward. So that's what this is doing. And then like if we hit A, it intends our character to go left, D, right, S, backward. So in a more simple explanation, imagine that the player is pressing a key to move forward or sideways. This node captures that intention before the character actually moves. So it's basically telling you this is where I want the character to go next. So then the is locally controlled. So this is actually a network-based node because what this is doing is it's checking if the character is currently controlled by the local player on the network. So it's very important in multiplayer games to differentiate between local players' characters and other players' characters. So it's like a way to ask, like, is this character being controlled by me on the computer, or is it somebody else? So it ensures that the certain actions or logic only apply to the player's own character, not others. So that's what we're checking for here. However, like I was saying earlier, we are going to get rid of this in 5.4 because we don't have any network-based stuff set up. And what this ends up doing that I've discovered is it doesn't control the character properly, especially within the game world, because what this does is this is based within the world space, not to the character's like space or the component space. So it doesn't make the CanSprint work right if these are set. So the only thing that we'll be doing is this going into the rotation from X vector into here. But now onto the rotation from X vector. So what this is doing is it actually converts a direction vector into a rotator that faces along that vector. So basically it assumes a vector represents the forward or x-axis direction. So in simple terms, if you have a direction you want to face, what this node will do is calculate the exact rotation that's needed in order to face the direction you intend to face. So it's like saying, given this direction, which way should I turn to look straight at what I want to look at? So I have, more of an example of this that I'll go over in just a moment. So let's go into delta rotator now. So what the delta rotator is doing is that it's calculating the difference between our two rotators. So basically it gives you like the smallest angle between two rotations, considering rotation wrapping. So for example, if this is at 359 degrees and this is at 1 degree, then what this is doing is it's calculating that change but in the smallest angle between them. So it's going to be, so if this is 359 degrees and this is 1 degree, then it is technically a 2 degree difference because a rotation around the circle is 360. So it's going to hit 360 and then go back down to 1, in order to check that change. It's not going to do a whole 358 to get that change. It's going to look for the smallest, closest way to get to that change as possible. So it's going to go, so if we got to go 360, so if I pull up, actually it'd be better if I pull up Paint, now that I think about it, because this will be better to show you. So if we get it right, so if I have my circle right, we have 360 degrees. That's what this represents. So say we're at here with 358, but then we want to go to 1 right here. It's not going to go this way to get to 358, or I'm sorry, 359. It's not going to go that way and do 358. It's going to take the shortest path to get there, which will be 2, because it's going to go 360 and then down to 1. It's not going to go 1, 2, 3 all the way up to 359. So it's going to get the lowest angle change in order to get our current change in rotation. So think of it as measuring how much does this character need to turn to face a new direction. So it's telling you the angle difference between where you are facing and where you want to face. So that's the deal there. So now with this, the reason why we're getting our Z is because we are trying to turn left or right, right? So if I go back into the character viewport, I don't know why I keep hitting S. So basically with here, what we're trying to check for our CanSprint is our yaw, which again is our left, and then our right when we look. So what we want to do is when we look to our left, it starts generating negative numbers. So if you ever do a print string and you do get actor rotation, you will start generating negative numbers going in this direction. But when you go to the right, you generate positive numbers. So what we want to do as far as a simple calculation is concerned is get the absolute float, so that way it returns a positive number instead when we look left. So then what we want to do is if we're looking left or looking right, we want to ensure that we are less than 50 degrees. So if we turn this way, you know, when we're sprinting, we want to make sure we're within a 50 degree rotation here. But then if we do go right, we want to make sure we're within 50 degrees here. So that is what that is doing. So we want to make sure that we're within a cone, more or less. So like a cone of movement. And if we are within that, then, you know, we pass it through here. But, you know, for our select, what we're trying to do is seeing if we are orienting our rotation of movement or if we're strafing. So if we hit play, what this is doing is this is our orient rotation to movement. So of course, if we're sprinting, it's always going to get the sprint no matter what. But then if we are strafing, we are not, you know, we're greater than our direction, which is going to be like, you know, if you sprint to the right or to the left, this is actually 90 degrees, which is going to be more than 50. So this is not going to work. So as long, you know, if we do a cone here, so if we go diagonally right, we're within 50 degrees. If we go left, we're within 50 degrees. So that's how we know, we can tell that we can still use this. So if we are rotating the movement, we just want it to always be true to where we're always just sprinting. But if we're strafing, we want to make sure that we're within the 50 degree cone in order to, you know, grab our sprint animations. And then lastly, we want to ensure that we want to sprint. And then if both of these sides are true, then return CanSprint. So now what we want to do is let's go in here back into our 5.4. So now that I ran through all of those, or actually let me go back real quick to 5.5, just because I wanted to give you more of an explanation to the rotation from X vector to kind of give you more of an understanding, right? Where, you know, it takes the directional vector and calculates a rotation that when applied to an object aligns the object's forward direction with that vector. So for this, you know, I did have to Google it because I was like, isn't this more or less dealing with yaw rather than the X vector, right? So, you know, what I've discovered from a common perception is that it might seem like the rotation from X vector primarily affects the yaw because in many cases, especially when the character movement is on flat ground, the changes in direction involve turning left or right. So what the reality of this node is that this calculates all three rotational components. So it does our pitch, our yaw, and our roll necessary to align the x-axis with any given vector. So if the vector points horizontally, meaning no vertical component, then only the yaw changes significantly. But then if the vector has a vertical component pointing up or down, the pitch will also change. So, you know, in a simple explanation, imagine you're pointing a flashlight. You have a flashlight representing your object's forward direction. The direction you want to point the flashlight is your directional vector. So the rotation from X vector calculates how you need to rotate your hand and possibly tilt it up or down to align the flashlight with that direction. So that is more of a, you know, better, hopefully, explanation to understand the rotation of X vectors. So that used to confuse me for the longest time, but because of those notes, I do have a better understanding of it now. So now back in 5.4, let's go ahead and do our next step. So we're going to go ahead and we're going to create a pure function for our CanSprint so we can throw it into here. So go ahead and hit plus on the functions over here in the left pane, and we're going to call it CanSprint. And before we continue any further, let's go ahead and make our function pure because that's what it has over there. And what we're going to do here is we're going to grab the character movement component, and we're going to then grab the get current acceleration from here. And then we're just going to move forward from here. So now I know in 5.5, you have the get movement input vector and is locally controlled. So like I said, the caveat to that is because there's a bunch of networking setup that's done in 5.5, I believe the is locally controlled and other stuff utilize like network, you know, based like functionality and stuff like that to determine those things, right? So in here, when I have done the testing, it does not work properly with the CanSprint here because we don't have network functionality set up in here for it to work properly like that. So what we want to do is just get the current acceleration and then drag off of here straight into the rotation from X vector and grab that. So then once we have that, what we want to do is get actor rotation. And then from here, we want to drag off actor rotation and get delta rotator and plug our rotation from X vector into the B. Then once you have that, let's go ahead and split the structure pin here, and we are going to grab the yaw and look for our absolute float, because again, when we are turning left or if we strafe left, it's going to generate negative directional numbers or degrees, and we want to make sure that that is converted into a positive value. So then off of that, we want to drag and get a less than node. And in here, we want to make sure that we are less than 50 degrees going left or right to ensure that we can still sprint. Then after that, we are going to grab a select node and grab a blank one. And we're going to grab our character movement component, and then off of this, grab your get orient rotation to movement, because we want to check if we are strafing or not from here. And we are going to then feed our degrees here into false and then set true to always be true, because if this is true, if orient rotation to movement is true, we want to always just play this, because we are always going to be facing forward no matter what direction we, press our key buttons in, right? So we want to always be able to sprint. But then if we are strafing, we want to check to see what angle we have when going forward, left, right, backwards. So then with that said, what we want to do now is we want to go into our variables in our left pane, and we want to grab the input and grab our wants to sprint and drag it out here. And then we want to drag from the wants to sprint to get our and boolean, because we want to double check that both of these are true in some way, shape, or form to let us know that we can sprint. So once you have that, go ahead and grab a return node and plug the and boolean into there. And then we have officially set up our wants to sprint here. So now let's go back into our get desired gate and go into our wants to sprint and delete that. And we're now going to grab our CanSprint to drag out here and throw it into our condition. And now let's compile and save. So when we finally sprint, so if we start sprinting and we go right, you can now see that we drop down to a run. So it now is properly working. So we have now officially cleaned up and set up the sprint animations from 5.5 to 5.4. So if y'all do want to test it, you're more than welcome to grab the get movement input vector and is locally controlled. But I'm going to bring over 5.5 just to show you again like why there's a caveat to that, right? So if the event tick off if you do a print string and do the CanSprint, like I said, if you do a sprint here, and depending on how you're doing it, so I'm still holding the sprint key, so my left shift, you can see that we still have true for the CanSprint, right? So, but as soon as I turn around, you notice that it changes to false, yet for some reason we're still sprinting. And so that false is because of this, because it converts it to a world space, and because we have networking functionality in play, we are getting the is locally controlled. So this is always going to be true because we are locally controlling our character in the animations to where this is going to play out, but then it gets world space related data and passes it through, which is why we end up getting false for the CanSprint, but yet we're still able to sprint there. However, if I go back into the 5.4 and I go into the event graph and let me go here, throw in our CanSprint, and you don't have to copy this, I'm just going to show y'all real quick. So if we do print string and we attach that there and I compile and save, Now, when I start sprinting, you notice that it's true. We are sprinting. We're good to go. But as soon as I turn, notice how it still remains true and we can still sprint. So that is why I'm saying that there's a caveat to that, because none of our stuff in 5.4 is network based unless you set up networking functionality yourself within your own project to where the is locally controlled will work with the other networking replication and functionality in order for you to, do that stuff. I got to make sure of what databases are missing. I believe we have everything. I'm trying to think of like what databases we're missing, because we have our jumps, lands light, lands heavy. What else am I missing? I don't think I'm missing anything else. Let's see, guys, before I leave y'all to it, because I don't want y'all to have to fight where the error is coming from. So we have our update movement set for our gate to where we are getting sprint out of here. If we want to walk, we'll go through here. So that's actually correct and set up. Let's see, we got our, let's go back into our characters, UEF and mannequin, and let's drill down for a moment to our sprint. Or actually, sorry, no, we want to go into our motion matching data. Go into databases, dense, sprint. Got our lands heavy, got our lands light. Actually, I might know what it is. So if we go back into motion matching data, go into post search database, and let's go into our idles. I'm pretty sure it has something to do with these. So I'm actually going to set the speed 2D down to 20 just in case. So let me see if that's what fixes it. That actually might be the issue. So before I leave y'all, let's see. Let's see. Checking. No errors that time. So I think that's actually what it was. Because I was trying to copy it from the game 5.5, but that actually could be what the issue was like you couldn't, because the speeds were vastly different, it couldn't get the proper animations. So that's probably most likely what it was. So yeah, if you do get that motion matching database error, guys, just go ahead and change the speed 2Ds to 20 and 20 here. I think it was probably because of the runs. It's probably what was actually messing up, because I feel like if we did 550 here, it probably wouldn't make a difference, because our sprint vectors and our calculate max speeds are at 700, so we're obviously going to be greater than 500. So you could probably actually get away with setting this to 500, but it's whatever. But other than that, that is essentially it. I believe we fixed the problem there. So that is it for the sprinting animations, guys. I, apologize that, it was a long video, but I tried to do this yesterday, and my video crashed when trying to do the crouch setup and stuff like that, and it was like way over an hour. So I wanted to try to separate these, because the crouching, just to give y'all a heads up, if you wanted to do it, by yourself, it is literally the same process as we did in the beginning of the video. Is you're going to go in, you're going to export all the crouches, you're going to do a bulk export, and you're going to export all of those to a location, and then just import them into the Game Animation Sample Project 5.4, and then go through that motion. You're going to literally do the same thing, and the crouching functionality is actually not that different, because in case y'all wanted to go ahead and do that before I release the video, essentially you'll see that we have calculate max speed for our walk and then our crouched walk. But when you look at both of these, the only thing that's different for one is that the use of this, but they use the same setup here as in 5.4, and then if you go into the update movement and do the crouch, literally the same setup here, except they just move the crouch speeds here. So, if you look at the 5.4 and we go into the update movement and get calculate max speed, literally the same thing, they just moved this. So that's all that's doing, to try to, fine tune the functionality. So that's what they're doing there. So if you're not worried about that, keep this as is. It's perfectly fine if you wanted to get ahead of the crouch animation. So other than that, dev team, that is it. Thank y'all for sticking with me till the end of the video. If y'all did enjoy this, please definitely check out my other videos that I have on the channel, and then also be on the lookout for my future videos to come. But other than that, y'all have been great. And, I want y'all to have a great rest of y'all's day, and take care.